Do you know what makes your phone charge, your lights shine, and your gadget work? It all comes down to three simple concepts: voltage, current, and resistance. Let's break down these fundamental building blocks of electricity in a way that anyone can understand. Consider subscribing in Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Let's start with voltage. Voltage is the driving force behind electrical current through a circuit. It's like the pressure in a water pipe that makes water flow. Voltage is measured in volts, and it represents the potential energy that pushes electrons through a conductor, such as a wire. When you hear 220 volts, 110 volts, that's referring to the amount of potential difference that pushing the electrical current through the circuit. Now, let's talk about current. Current is the flow of electric charges. Imagine that same water pipe analogy. If voltage is the pressure, then current is the flow of water itself. In electrical terms, current is measured in amperes, or just amps. The more amps, the greater the flow of electricity. Current can be direct DC, where it flows in one direction, or alternating AC, where it periodically changes direction. The third piece of the puzzle is resistance. Resistance is what limits the flow of current. It's like having a narrow section in your water pipe, making it harder for water to pass through, or friction that slows down the water flow. In electrical circuits, resistance is measured in ohms, and it determines how easily current can move through a material. High resistance means less current flow, and low resistance allows more current to pass through for a constant voltage. All materials offer some degree of resistance, and how much depends on the type of material and its properties. For example, metals like copper have low resistance, allowing current to flow easily, while insulators like rubber have high resistance and blocks the flow of electrons. The relationship between voltage, current, and resistance is captured by Ohm's law. V equal I times R. V is voltage, I is current, R is resistance. If you increase the voltage and keep the resistance constant, the current will also increase. So V and I in this condition is directly proportional. If you increase resistance while keeping voltage constant, the current will decrease. So R and I in this condition is inversely proportional. To understand it better, consider a practical example. Think of a simple circuit with a battery, a light bulb, and wires. The voltage from the battery pushes the electric current through the wires and into the light bulb. The resistance of the light bulb filament limits how much current will flow. The interaction of these three determines how bright the bulb will glow. Understanding these three concepts will give you a clearer picture of how electrical circuits work, whether you are wiring up a light bulb or designing a complex industrial system. If you found this breakdown helpful, consider subscribing in Electrical Engineering Planet channel to support our community. Also, don't forget to share, like, and let knowledge enlighten your world. Thanks for watching.